Question. We've got secant theta minus tangent theta square on the left hand side. On the right hand side, we've got a fraction. So you should be able to tell that the left hand side seems a little more complicated. There is something that you can do to the left hand side, and that is you can expand the left hand side. So starting from LHS, we get secant square theta minus 2 times of secant tangent plus tangent square theta. That's our left hand side. Now we have the option to rewrite everything in terms of sine and cosine, because that's the other approach that we will take. And we see that the right hand side is solely in terms of sine only. So let's see what we can achieve from there. This is 1 over cosine square theta, 2 over cosine theta. Now tangent theta will become our sine over cosine. Sine theta. Then instead of writing another cosine at the denominator, let's just change it to cosine square theta. And you should be happy to see this because right now you have two fractions with the same denominator. I think you are headed in the right direction. So plus sine square theta over cosine square theta. So you see everything is in terms of cosine theta, cosine square theta in the denominator. Now we get to combine 1 minus 2 sine theta plus sine square theta over cosine square theta. Okay, the next step is going to be crucial because apparently we will be able to get rid of all the cosine, and that appears only in our denominator. Is there some way that we can change this cosine in terms of sine? In addition, our numerator, the sine square is going to disappear, and we are going to have the numerator as in a way linear. We're not going to have quadratic. Change sine square to? What can we do? What about the cosine square? I think it's easier to change our cosine square in terms of sine. 1 minus sine square theta, yes. So 1 minus 2 sine theta plus sine square theta over 1 minus sine square theta. Okay, at this point, it may not look like you made things easier for yourself, but you stare closely. I've got one fraction, numerator, denominator. Definitely the numerator, they are going to be related. Definitely denominators are going to be related. How do we get a 1 plus sine theta from a 1 minus sine square theta? I think it would be very sensitive to a 1 minus something square. Isn't that the difference of two squares? Right? A square minus b square. Right? That's so we'll be able to write this as a plus b, a minus b, right?
So sine square theta is the same as sine theta square, right?
Yes. So a plus b, a minus b. Okay, let's see. In our denominator, it becomes 1 plus sine theta, 1 minus sine theta. Is that going to be helpful? Compare with the original. What they want you to prove. 1 plus sine theta. Oh, you have the 1 plus sine theta. But you have a problem. You have this 1 minus sine theta also. But what would that tell you about the numerator? If the denominator has this very irritating 1 minus sine theta, which you don't want it to appear, what do you think we will see in the numerator also? You must see the 1 minus sine theta also, right? Then there's a chance for you to cancel. So they are actually giving you a clue that maybe you can factorize the numerator, and one of the factor is 1 minus sine theta. You get what I'm trying to say? That's the approach, huh? Now this is a quadratic in the numerator. Can I factorize out a linear 1 minus sine theta? Do you think it's possible? You have to see it as possible. And now we examine the numerator again. This is 1 minus 2 times of something plus that something squared. Does this sound familiar? 1 minus 2a plus a squared. Can you factorize that? Now you can do it this way. 1 sine theta, sine theta. So we get 1 and sine square theta. We want a result of negative 2 sine theta. So we will allocate the negative signs this way, which means our numerator is now factorized to become 1 minus sine theta times 1 minus sine theta. And one of them is going to cancel off. Then we are reaching the final step already. So this 1 minus sine theta, 1 minus sine theta. So you could have also realized that from the numerator, we actually have a squared minus 2ab plus b squared, where your a is 1 and your b is sine theta. So from here, we have proven 1 minus sine theta over 1 plus sine theta. Proven. Okay, so the strategy didn't change. We start with the complicated side, something that we can start off with. Convert everything to sine and cosine. So next part, B. We've got part 1. Find the value of k in radians per minute. Okay, so let's try to understand this first. We've got a minute hand that is rotating clockwise. The length, the distance from the center to the tip of the minute hand is 80 cm. So this minute hand is rotating. The distance of M from the vertical line through O, and so on and so forth. This is the relationship. D equals to 80 sine kt with modulus. To find the value of k, let's examine this equation over here. D modulus 80 sine kt. What is the period of one cycle? How long does it take to complete one cycle? So yeah, 60 minutes. So the period is 60 minutes. Okay? Now how do we get the period from a trigo expression? Remember we said that y equals to cosine theta, the period equals to 2 pi, right? So y equals to sine theta, the period also equals to 2 pi. For example, y equals to sine of 2 theta, the period, what is this period? When it is sine 2 theta? 2 pi over 2, and that is pi. This is the relationship that we're going to be using. We take 2 pi divided by the coefficient of this angle. Okay? So now, the coefficient is k. Right? The coefficient is k over here. Which tells us that the period is going to be 2 pi over k. So now we have formed one equation with one unknown. 60 is equal to 2 pi over k. That must therefore mean that k equals to 2 pi over 60, which is pi over 30. Okay, take some time to digest this first. How we are obtaining two different expressions for the period. First, common sense, 1 hour, 60 minutes. It takes 60 minutes to complete one cycle. Therefore, period equals to 60 minutes. The other is by using the expression, we are using the coefficient of the angle in our trigo ratio to determine the period. So I give you one more example. When y equals to sine 3 theta, the period is 2 pi over 3. So we are using that relationship over here. We get 2 pi over k. Equating them together, pi over 30, that is our value for k. Let's check whether the units are in radians per minute. So go back to your original form for k. Now here we see 2 pi in the numerator. The unit for 2 pi is radians. The unit for 60 is minutes. So when you divide them, you get radians per minute. So it tallies with the units over here. So this is in radian per minute. Alright, now moving on to part 2. For how long is each hour? In each hour is d more than 40. Okay, so I will use a graph to help us visualize what's happening over here. I am going to plot d against an angle. Now, horizontal axis, we are very used to our horizontal axis being x, where x is the angle, or theta, where theta is the angle. We are also used to the horizontal axis being t for time. Now, but in this case, we have d equals to modulus 80 sine kt. You have a few options for the horizontal axis. I will use kt as the horizontal axis. Okay, keep in mind that k is a constant which we already found. T is time. So if my horizontal axis is kt, you can look at it as d equals to modulus 80 sine kt. Okay, or to simplify things even further for you, let theta equals to kt. Okay, so now I am going to sketch the graph of d equals to modulus 80 sine theta. Okay, now this shouldn't be a problem to you anymore, yes? I'm going to sketch d equals to modulus 80 sine theta, where theta is equals to kt. So in one cycle, I'm only interested in one cycle for now, because they are talking about for how long in each hour. 1 hour. 1 hour, 1 cycle. So one cycle, I'm going to divide this into our standard 4 parts. 1, 2, 3, and 4 parts. In one cycle, the angle is 2 pi. This is pi, pi over 2, 3 pi over 2. What is the shape of our sine graph? It starts from 0. It reaches a maximum point. It goes down to 0 again. Goes down to the minimum point, and it goes up. This is 1 and this is negative 1. But because I want 80 sine theta, my maximum is changed to 80. My minimum is changed to negative 80. Because I want to modulus it, I'm going to remove whatever is at the bottom. I'm going to reflect it upwards. So going up, remove the bottom. This is now my graph of d equals to modulus 80 sine theta. Okay, so far? And they are interested in the range of the time when the value for d is more than 40. So draw a dotted line across. Draw a dotted line across. And this is 40. We want to find out this particular value. Where the value for d is first equal to 40. I am also interested in this value when it next becomes 40. Then the third time it becomes 40. And the last time it becomes 40. These are the points that I am interested in. Because within 1 hour, within the one cycle, otherwise known as 1 hour, there are times when the value for d is less than 40. Then it is more than 40. Then it becomes less than 40, less than 40, more than 40, and less than 40. Okay, so far? So, when is the first instance that it is equal to 40? We will now need to equate d, which is 80 sine of theta. Notice that I have removed the modular sign. Because the first instance when it is equal to 40, it was it was on the positive region of our modulus. Okay, it was only the second half, then it is a negative. So for the first value of the angle, I can conveniently remove the modular sign. Okay, now, and this is equal to 40. So apparently sine theta equals to half. What is the basic angle? Theta is sine inverse of half, giving us a value of 30 degrees. Okay, you can use your calculator to find out. 30 degrees in radian, that will be pi over 6. Cancel over. Okay, so the first instance, this is pi over 6. Now by symmetry, can you tell me what this value is? If this is pi over 6, what must this be? Okay, where is the symmetry? This range over here must be the same as this range. So pi minus pi over 6, that gives us 5 pi over 6. And we can do the same over here. This is the same pi over 6. This is the same pi over 6. Now with all this information, where exactly is the region that I want when the value for d is more than 40? This is the region where d is more than 40. And it is repeated over here. So meaning once I manage to find the time in this region, I multiply by 2, I get an answer. Okay? So, what is the ratio of this green portion over the first half? Can we do that? I think we can. If this is 5 pi over 6, this is pi over 6, this green region has a total distance of 5 pi over 6 minus pi over 6 to give us 4 pi over 6. Okay, so far? This is 4 pi over 6, which we can simplify to become 2 pi over 6. So this is 2 pi over 6, 2 pi over 3. This is 2/3 pi out of pi. 2/3 pi out of pi is the proportion when the value for d is more than 40. So we can actually double that and we divide it by 2 pi to get a total proportion of the time that it is more than 40 within one cycle. So what is 2/3 of an hour? Because this is over here the first green color portion, 2/3 pi out of pi. That is 2/3 out of half an hour. Right? Then after that we need to double it because that is within 1 hour. So effectively we are looking for 2/3 of an hour. That will be 40 minutes. Okay? So presentation wise, after we found 2/3 pi, we can multiply it by 2. Or you could have finished it over here and take 2/3 pi divided by pi. Alternatively, I'm going to show you the longer way, the more complete one, which will be 2/3 pi times 2 out of a total of 2 pi. What we have over here is a fraction. This is the proportion of the time that it is more than 40 but less than 80 within 1 hour. So now we need to multiply this by 1 hour, which is 60 minutes. And we get the pi and the pi cancel, 2 and 2 cancel, 2/3 of 60, 40 minutes. So part 1, explain why p equals to 2. According to the Cambridge report, you shouldn't have problem with that. But for part 2, that's where many students were unable to get a full 4 marks when they sat for this paper a couple of years ago. To determine the value of A, B, and C, you can use the suggested method in your answer booklet. I'm going to show you an alternative. They tell us that A is more than 0. So this means that it is a parabola opening upwards, originally. So without the modular sign, we are supposed to get a graph that looks like this. Okay? It is supposed to be a mirror image. So this minimum point over here at the bottom has coordinates of 4, -6. Okay, and now I am going to ignore this. So what I have now is that I have the coordinates of A, which is 2, 0. I have the coordinates of B, which is 6, 0, and the coordinates for the minimum point, which is 4, -6. I have three sets of coordinates. That means I have 3 x and 3 corresponding y values. The equation of the graph is now going to look like this. Y equals to ax squared plus bx plus c. I have removed the modular sign to make it correspond with my original graph. Okay, so I'm reversing it. Remove the reflected region, get the original parabola without modulus. And this is the equation without the modulus. 3 equations, 3 unknowns. Right, we see A, B, and C are the 3 unknowns. I can form 3 equations. Substituting A, 0, A times 4 plus 2B plus C. That's equation number 1. Equation number 2, 0 is A times of 36 plus 6B plus C. Equation number 2 and equation number 3. -6, A times of 16 plus 4B plus C. With 3 equations, you can solve for 3 unknowns. So go and try this out. Alternatively, use the method given in your answer booklet. Then for part C, according to the report again, for part 3, you shouldn't have problems with this. The next question I'm going through is question 7. Okay, no. Since I only have 5 minutes left, I'll go through question 8 first. So we have a triangle with the following information. Now find the coordinates of B. Remember, we are doing A maths over here. When they tell us there is a perpendicular line or perpendicular lines on 90 degrees in coordinate geometry, most likely it is going to involve product of gradients to give us -1. So with this equation here, I can find the gradient very easily. From here, the gradient is, let's rearrange. So 2y -3x plus 45. Y -3 over 2x plus 45 over 2. This is the gradient for BC. So I can get a gradient for AB. Gradient is 2/3. Right? Change the sign, flip it over. So with the gradient and one set of coordinates, I can find the equation of AB. No problem. Once I get the equation of AB, I can do simultaneous equations with BC. Where they intersect will be point B. So that's 5 marks. Part 2, M is the midpoint of AC. Okay, so do a rough sketch. Okay, so this is my value of M, my position for M. They tell us that A, B, C, D is a rectangle. Draw a quick sketch. My rectangle should look like this, and this should be point D. Find the coordinates of M. Okay, since I have the coordinates for A, I need the coordinates for C. It is the x-intercept for this equation. These are irrelevant already. X-intercept happens when y is equal to 0. Set y equals to 0, find the value of x. You get the x-intercept. Once you have the x-intercept, midpoint is just going to be half of the distance from -2 to whatever this value is. Add them up, divide by 2, you get the average. That will be the x coordinate. The y coordinate is much easier because this is 0, this is 6, this must be 3. So I have outlined the process for finding the midpoint, the coordinates for M. To find the coordinates for D, you need to know that another property of a rectangle is that the diagonals, they bisect each other. So M is going to be the midpoint for BD as well. Then we are going to have to work backwards. For whatever value of coordinates of B that you found earlier on, let's call it P, Q. And we already have the coordinates for M. To find the coordinates for D, let's call D as x1, y1. We'll form more equations. P plus x1 divided by 2 is the x coordinate for M. Q plus y1 divided by 2 will be the coordinate, the y coordinate for M. So 2 equations, 2 unknowns. Yes?
So sometimes diagram questions, I want to have a point, can I extend just put x down there and say ax to xd?
If the diagram is also, if your working is just below the diagram that you are using and you indicate it in the diagram, then it's fine. Okay, so now paper 2, they will also give you space to do your working. You won't be doing on foolscap, separate foolscap anymore. So meaning you have easy reference to the diagram lah. It's like paper 1. Okay? So part 1, part 2. Question 7 now. A few more seconds left. So we have a a cyclist traveling west 5 meters per second. And another cyclist 100 meters from O cycling towards O. So here we have 90 degrees. Then after some time, they will reach their own respective points. Express OP and OQ in terms of T. So we're going to be using, you can use this information, this formula. Distance over time, you get your speed. So do the substitution to find OP and OQ. Once you have an expression for these two, then the distance of PQ, which is S, is found by using Pythagoras theorem. That's where they get a square root from. So once we have the expression for S, we can differentiate. Even if you didn't manage to prove part 1, you can differentiate the expression over here by yourself easily. Once you have the expression for ds dt, to find the least distance. So least over here, you're talking about the minimum point. So you set ds dt equals to 0. Then you get a value for t. But there is no guarantee that this is a minimum or a maximum. So you will need to d2s dt squared. Substitute in, confirm that you are getting a minimum point, or you can use your sketch to determine that it is a minimum point.